Today we're going to talk about intersection of lines. So when two lines intersect, that means they are crossing at a point. So we want to know, where are these lines crossing? So our first question says determine the point of intersection. So if I take a look at my first graph, and I apologize, it looks better on the handout than the ones that I drew here, but I have a red line and I have a blue line. Do those two lines meet? Yes, they do. They meet at this point right here. Now, when I am finding the point where they intersect, we always do x first, which is the side to side, and then y, which is the up and down, which is opposite of slope. Slope, we always do y first and then x. But when you're stating a point, we always do x first and then y. So on the x part, this is at 5, and on the y part, this is at 4. So my point of intersection, that's what POI stands for, point of intersection, is the point 5, 4. We always put the x part first and then the y part second. All right, what if I take a look at the next two lines? So I have the red line and the blue line. Do those lines meet? No, they do not. Do I think that those lines will meet eventually, maybe somewhere off the grid? Well, I'm not really so sure about that. If I look, say, here at the y-intercepts, I notice there's a gap of 1, 2, 3, 4, 5 squares in between them. If I come over here, I notice there's still a gap of 1, 2, 3, 4, 5 squares. If I come up here, I notice there's a gap of 1, 2, 3, 4, 5 squares. So these are evenly spaced. There is the same amount of distance between them all the way along the line. So I don't think these are ever going to meet. I think they are just going to continue to be evenly spaced. There's a reason for that. That is because these lines are parallel. Lines that are evenly spaced and do not meet are parallel lines. So when it says point of intersection, I'm going to write none. And then I am just going to make a note, and there is room for this at the bottom if you've printed off the sheet. I am just going to say that the lines are parallel and do not meet. Okay, our last set of lines are a little weird because I only really see one line. Now I can kind of tell there's a little bit of red and a little bit of blue, but it really is just one line. So where do these lines intersect? Well, the two lines are just sitting one on top of the other, which means they intersect at every single point on that line. That's where they touch. They touch everywhere. They are intersecting everywhere. So because they are the same line, they intersect everywhere along that line. So when I go to say point of intersection, I don't want to have to write every single point down. I couldn't write every single point down. We would be here for the rest of our lives. So I'm going to say infinite points. Infinite means there is no end. And I am just going to make a little note that I'm going to say they are the same line. And meet everywhere. Okay, so every point on that line is an intersection point between them. So there's an infinite number of points because they're the exact same line. So when you have lines that intersect, they can intersect at a point, and then you just state the coordinates. They could be parallel, which would tell me that they don't meet at all, so they would have no point of intersection. Or they could be the exact same line, which means they would have infinite points of intersection because they intersect everywhere. So we are going to try graphing some ourselves, and then we'll see if we can find their points of intersection. So our question number 2 says graph each line and determine the point of intersection. So I have y equals negative 3 over 2x plus 2 and y equals x minus 3. Now I find it helps me if I write down the slope and the y-intercept. but that's up to you. That's why I left a little space there. So I'm going to start with the y-intercept. That's 2. And then the slope, which is negative 3 over 2. Now you have to choose whether you want that negative to go with the numerator or whether you want the negative with the denominator. I like to always put it on top, so I like to do negative 3 and then over 2. For the second one, we'll get to the second one in a second. I'm going to try graphing this first. So for my y-intercept, that's where we always start. We need a starting point for our graph. So on the y-axis, I am going to find the number 2 and make a point. From there, the slope is the roadmap that tells me how to get to the next point. So the part on the top tells me how the y value is changing, and the part on the bottom tells me how the x value is changing. So my y value should be going down by 3, and my x value should be going up by 2. So if I start at this point, the y value, or the up and down part, is going down 3. So I'm going to go down 1, 2, 3. And then the x part is going to go up by 2. We're adding 2, so I'm going to move over 1, 2. And then make a point. And then I do it again. We're going to subtract 3 from y, add 2 onto x. Subtract 3 from y, add 2 onto x. Subtract 3 from y, add 2 onto x, and then do it in reverse going the other way. And if you can reverse the pattern, that's great. If you find that too challenging, you can just turn your page upside down, and then that way you just keep going down 3 and over 2. Okay, I'm going to draw my line. Okay, so there is line 1. Now it's a good idea to label or color code or something so that you know and I know which one is which. So I'm going to call this number 1, and then I just put a number 1 next to it. Okay, for the second one, I have y equals x minus 3. I'm going to identify the y-intercept and the slope. So for the y-intercept, that's the number without the x, which is the negative 3. And then for the slope, there is no number in front of x, or is there? There is a secret 1 hiding in front of that x, so the slope is actually 1. And the slope is always the change in y over the change in x. So I don't see a denominator. There is a secret denominator of 1. Okay, so I'm going to start by plotting my y-intercept. So on the y-axis, I'm going to find negative 3 and make a point. And then from there, we are going to add 1 onto y and add 1 onto x. So our y value is going to go up 1, and our x value is going to go up 1. So we're going to move over, and we added 1 to x, added 1 to y, added 1 to x. And then I'm going to add 1 to y, add 1 to x, add 1 to y, add 1 to x, add 1 to y, add 1 to x. And I just keep doing that until I run out of space. And then I do it in reverse. And then I'm going to draw my line. I'm going to call this line number 2, even though I did color code. Okay, so I have graphed line 1, I have graphed line 2. Am I done the question? No, because the question wants to know the point of intersection. So do these two lines meet? Yes, they do. They meet here at that point right there. So when we're doing the coordinates, we always do x first. So my x part is 2, and then I do my y part, which would be negative 1. So you could say, therefore, you could write POI equals, you could say they intersect at, and then state the point. It is your choice. I'm going to say they intersect at, this is the point 2, comma, -1. Okay, and that's all you really need to know for today on intersection of lines.